Hi, are you planning to deploy Deepseek on Amazon EKS with an optimal architecture? Yes, we are going to deploy Deepseek VLLM on Amazon EKS auto mode using GPU and inferentia instances. Let's get started.
In this module, we will learn how to create Karpenter custom node pools for GPU and Inferentia based EC2 instances. Let's get started.
Okay, so in this section, apart from using the default node pools, let us see how to create the custom node pools. Okay, now let's go to this path. So I'll copy this path. So if you see, there are some template files. Okay, now I'm setting the region to US East 1. The cluster name I'm getting from the Terraform output. Okay, so then I'm getting the node IAM role also from the Terraform output because I know this name already because I'm using a particular name while creating the cluster. And the subnet ID is 1, 2, 3, the security group ID, all of them I'm getting from the Terraform um, directory itself, right? From the output, I'm just running the Terraform output and getting the values for these variables. Okay. So to run this command, so what I will do is I will go back to my terminal and I've gone to this particular directory, which is the AML, AML auto mode 1 cluster. Okay. This is where I can run the Terraform output commands. So let me run this command to see how it works. Okay. So for example, I'm just copying this cluster name command. Okay, the cluster name is created, displayed here. Now let me run the other commands also. I'll just copy all of these commands and run in one shot to save time. So you see that the Terraform output is providing the JSON output for this subnet. So I'm just piping it to JQ command and displaying the entries in that array. So this is subnet 1, 2, 3 IDs and there is a security group IDs as well. Okay. Now all of these variables are set in the environment section in the bash shell. Now let me run the other commands. Okay. So let me first go to this directory. This is where all my custom node pools are created. The template files are there. So let me run this command. So if you see ls, so I see the template. Okay. So now I'll just simply copy this command. So basically it is substituting some environment variables in this file. So let us see how this file looks like to get an idea. Okay. Now this is my node pool folder. So if I just expand this, this is my template. In the template, so this is an IAM role, subnet ID 123 and security group. This is a node class. Okay, I'm creating a custom node class called accelerated-br. Okay, and this is using the Karpenter node IAM role and subnets security group. And this is the node pool, which is the accelerated-br-GPU. Okay, it's a GPU based node pool, and most of this configuration is same as the default node pools. So here I'm using one label np, stands for node pool, np colon, this is the value, and I'm using some annotations as well. And in the node class references, I'm using the accelerated br, okay, the one which I'm creating here. Okay, now if you look at the specification, I wanted to use all the GPU based instances. So it could be G5, G6, G4, P2, P3, P4. I'm not using P2, but yeah, P family. And in these regions, availability zones, and AMD, I'm using on demand and Linux. And I'm also using the taint called nvidia.com/GPU. So I'm also providing some limits. Okay. So this is what I'm creating a node pool for the GPU. Okay. So if I run this command, substitute this template files. So let us see whether the file will be created or not. Okay. So this is a file which is created. with all the values substituted. Okay, so let me apply this YAML file to deploy the custom node pool. So as you see, the custom node pool is created and there is a node class is also created. Okay, now let me run this command get node pool to see whether it is created or not. Okay, you see the accelerated-br-gpu is the node pool, which is custom node pool. This is the node custom node class and it is true just 17 seconds ago. So it's a new one created just now. Okay, and node class also I can check. Okay, so here you will see two node classes. One is the default, another is the accelerated-br. Okay, so this also created successfully and using the same node IAM role that is used by the default. Okay, so let us understand the specification. Okay, how does it look like? So I'll just run this command just to get an idea so how the specification looks like for the node class. So if you see specification, the security group ID is this node IAM role, and these are the subnets that we have provided. Similarly, for the accelerated BR GPU node pool, I can run the command to see the specification. So this is the specification for the node pool. So you see the instant types that we provided and the other configuration. So far we have created the custom node pool for the GPU. Okay. Now we'll create one more custom node pool for the Neuron. Okay, because these two are different set of families. So creating the custom node pool for the Neuron is also very much same as what we have done earlier. So I'll just simply run these commands. Okay. Now if you see, this is the generated file with all the values substituted. So if you see the substitution for the values, so these are the subnets and this is the same node class I'm using, and this is the br-neuron, and this is the label. Okay, np colon this, and this is the set of instant types. Okay, in the previous GPU the instant types were different, but in the inferentia the instant types were different. So this is the primary difference, and the taint is also different. Previously it was GPU taint, now it's a Neuron taint. So this is important because we have to apply the corresponding toleration to deploy the applications. Okay, so let me apply this. Okay, so the node class is already there, so it's unchanged, and the Neuron node pool is created. So let me run the similar commands to get the newly created node pool and the node pool. Node class was already there. So this is the newly created Neuron node pool. Okay, and we can just see the specification for the node pool alone, because for the node class we have already saw that. So if you see, this is the specification. The node class is same, instant apps are different. These are the various availability zones, AMD, on demand, and this is the taint. Okay, so these are the set of commands to create a custom node pools for GPU and the Neuron. Okay, now let us proceed to validate whether these node pools are really working or not. Okay, so that's where we will deploy some sample application and test. Okay, so I'll go to this folder. If you see the list of files, inflate-gpu and inflate-neuron. Okay, so let me do cat and see the specification for this. Okay, so it's a simple POS container and I wanted to deploy this on a specific node selector label. So this is the BR-GPU, and I wanted to provide one resource, GPU colon 1, right? nvidia.com GPU colon 1. So this is the simple test pod, okay? Deployment specification to see whether the Karpenter will create a node for this or not, right? So let me deploy this. Okay, so let us put a watch on the nodes, and let's also look at some node claims as well. Okay, so in another terminal, I'll put a watch on the node claims also. Okay, and in the another terminal, I'll put a watch on the parts just to see um, the progress of all of these resources. Okay, so you see the accelerated-br-gpu node pool has created one node claim, and it is creating g6.xlarge on demand in US East 1 just a few seconds ago, right? It is not yet ready. Okay, let us give it some time. And in the node also, get nodes also, it's not yet registered. Okay, so let us wait for a few more seconds. In the pod also, it is still pending because there is no node ready yet to join the cluster. So let's give it few seconds. So now it is ready. If you see the status, it is true. So let me see the get nodes also, it is true, join the cluster. Now the pod should be running now. Okay, so that means Karpenter is creating a node based upon the custom node pool, right? Now let us also look at the um, describe command, okay, to see what kind of information we have about this node. So okay, let's go to the console. I'll just stop this. Okay, I'll see get node. So I'll do get, describe node command. So you can see various information, and this is the set of labels. Okay, so the compute type is equal to auto, so it's created by auto mode cluster. Lot of other labels you can see, and you can also see the nvidia.com/gpu 1. So the custom resources, the accelerated resources are also advertised, right? So if you notice, we have not deployed any device plugins. Normally in the GPU or the Neuron, we have to deploy the GPU or the Neuron device plugins, so that those plugins will advertise the accelerated devices to the API server, right? kubectl. But here we have not done that anything. We just created the EKS mode cluster, auto mode cluster, right? The auto mode cluster AMI, the auto nodes are doing everything for us. That's the best part, right? So I have not deployed any other add-ons or anything. So if I see get daemon sets in the cluster, you don't see any daemon sets also running in the cluster. Unlike in the normal cluster where you will see a lot of device plugins, schedulers, various other controllers, nothing is there, right? So it is completely automatic. Similarly, if you wanted to see the pods, apart from our pod, is there any other pod running in the cluster? If you see, there are no other pod, just our pod itself. So that means all the system capabilities like uproxy, CNI, everything is already taken care using the auto mode. Okay, so that's all for this demo where we have created a sample application of the GPU. So we can go ahead and delete this uh, application. Okay, now let us validate the same thing with the Neuron also. Okay, so the configuration is very much straightforward, but let me just do a cat and see. So here you will see np colon accelerated br neuron, and the device type is this, right? Unlike GPU, it's neuron, and rest of the configuration pretty much same. Okay, so now I will simply do apply. Okay. We can do the same thing. I'll put a watch on the node, and there is a watch already available on the node claim. Okay. And there is a watch available on the pod as well. Okay. So let us give it a few seconds for the Karpenter to bring a node. Okay. So you see the inferentia 1.xlarge is already launching right on demand in this particular AZ, and it is launched by this custom node pool. Okay, so eventually it will be ready. So it's already ready so fast, and our pod also should be able to running state. So that's the best part. Here I have not deployed any Neuron device plugins or Neuron schedulers, nothing of that sort, isn't it? So that is the best part of using auto mode with all the capabilities inbuilt into the AMI itself, and the cluster control plane as well, of course. Okay, so far we have created an EKS cluster in auto mode and created a custom node pool and also validated the node pools. So let's go ahead and delete the Neuron sample file. Okay. So the corresponding node also will be deleted eventually. So you can just check here as well. So for the node claim will be deleted and the node also will be deleted eventually. Okay.